Okay, so some examples determining the polarity of compounds. First off, you guys now should be pretty fluent in drawing Lewis structures. The biggest issue that you have to take on here is your Lewis structures can sometimes be deceptive because they don't reflect the three-dimensional shape that you guys learned about with Vesper. So you have got to think about the three-dimensional shape if you determine a compound to be symmetrical or asymmetrical. So let's go through a few. HCl. H bonded to Cl. Symmetrical or asymmetrical? Asymmetrical. You have a polar bond. This is what type of substance? Polar or nonpolar? Polar. Polar. Good. H2O. If you draw it, you can draw it like this. But again, look at your Lewis structure. You almost draw it in a way that shows it to be symmetrical. Is water symmetrical? No, remember up here? We just looked at it. It is asymmetrical. We know water to be polar or nonpolar. If it's asymmetrical and there's two distinct poles, it is polar. CO2. C double bonded to O, C double bonded to O. What's the shape of this with Vesper?
Linear.
Linear. Is it symmetrical? Yes. So is it polar or nonpolar? Non-polar. NH3. Again, here's another one that can be somewhat deceptive, but you guys have already seen this a lot with Vesper. Symmetrical or asymmetrical?
Asymmetrical.
Asymmetrical, it's a trigonal pyramid. So, polar or nonpolar? Polar. C2H2. You guys have done this one. See what I mean about these examples repeating themselves? So, this is linear, symmetrical or asymmetrical?
Asymmetrical.
Symmetrical, it's linear. So, polar or nonpolar? What?
Non-polar.
Nonpolar. Good. All right, one more. C, H, Cl3. Symmetrical or asymmetrical? Asymmetrical. Positive pole, negative pole. So overall, it must be polar. Now, all of these are homework 32. All these examples are homework 32. So I have it right here in your notes, but you can click over to homework 32 and you can actually put all of this in your homework notebook and complete this homework assignment.